Today we are going to be solving systems using tables and graphs. Well, actually, we're not going to use tables. We're just going to solve them by graphing. A system just means that there is a set of two or more equations. So there are three types of solutions when you're solving. We have one solution if the two lines that you graph actually intersect in one point. We have infinitely many, meaning the two lines will be, or actually graph the same line. And then we have the solution if the two lines are parallel. That would be no solution because they aren't touching. And so we call these, we have special names for each of the three solutions. Okay, and this is how we classify them. If they intersect at one point, it's one solution, and we call it consistent independent. Think about independent meaning one. Infinitely many solutions would be if the two graphs graph the exact same line. And then, of course, parallel lines would be no solution, and we call that inconsistent. If it's infinitely many solutions, that is consistent dependent. So you have a consistent independent, a consistent dependent, and then you have an inconsistent. Those are the three types of systems. And you can actually classify them without graphing. And the way that you do that is you make sure that your two lines are in slope-intercept form. And I'm going to do this for each one because I'm going to Okay, so for the first one, these two equations, and I better make them, are going to be totally different. And they're going to actually intersect in one point. Okay? Then you have the second one. This is going to be the same exact equations. They're going to be exactly the same. And then these two will only have the same slope. But the y-intercepts are going to be different. So these will be different. Okay? So that's how you can just look at the equations and tell or classify the system. So they'll either be totally different equations, same exact equation, or only the same slope but different y-intercepts. And you want to make sure when you're graphing that you use graph paper because it's going to make it much easier to see where they're going to intersect, if they intersect. Okay, here's my system, and we're going to solve it by graphing. But the first thing we have to do is get both equations in slope-intercept form. So here are my two equations, both in slope-intercept form. And now I'm going to graph them. So I'll graph. And I'll just put my little tick marks. And I'll start with the first one. So my y-intercept is 4. And I'm going to go up 3 over 2. up 3 over 2, or I can go down 3 and left 2. And you may have to do your slope a couple of times so you can see where they're going to intersect. You might want to find something straight to graph the line. It's a little off. And then my other one is at -4. I'm going to go up 1, left 2, up 1, left 2. And if you notice, they intersected at -4, and it's hard to see, but it's supposed to be -4 and -2. And if you ever are in doubt, you can always plug in the x and y values to make sure that they make both equations true. So what I mean by that is you'll plug in -4 for x and -2 for y and see if it equals +8 for the first one. So that's 12 minus 4 equals 8, and that's true. And then the second one, -4 plus 2 times -2. So we got -4 minus 4, that equals -8. So that one's true. So this is an example of an independent, consistent independent solution. Okay, and make sure you label the point where it intersected. Okay, try this guided problem. First thing you want to do is get both equations in slope-intercept form, and then we're going to graph it. And pause the video so you can see if you got it right. Okay, so look at my two equations in slope-intercept form. And I graph both of those using the y-intercept and the slope. One slope was negative, the other one's positive. And then I saw that they intersected at 2, -1. So this is another consistent independent solution. Now we're going to, without graphing, classify each of these systems. Remember, we can classify them by putting them in slope-intercept form and comparing their slopes and their y-intercepts. Remember, if they're totally different, that is a consistent consistent independent solution. If they have the same slope, just same slope only, that's inconsistent, which means they'll be parallel. And if they are exactly the same, that is a consistent dependent system. So let's try these three. So first thing I'm going to do is get my first equation in slope-intercept form. And then the second one, we have to do two things. And then multiply everything by -3. Alright, so if you notice, the slopes are the same, the y-intercepts are different, which means these two lines are going to be parallel, and that's going to make them inconsistent. Okay, and let's try this one. And you divide everything by 3. Don't forget to divide every term. And then the other one, we're just going to subtract the 4x. If you notice, these two are totally different, which means they're going to intersect at some point. So this is independent. Consistent, independent system. Now I'm going to let you try the last one. Pause the video and try it, and then we'll check it. Okay, if you notice, the first equation was already in slope-intercept form. The second one had to be converted to that form, and they are the exact same. So this means that they will graph the same exact line, which will make it consistent dependent. So that's how you classify them without graphing. Our last example is a word problem, and later we're going to learn how to solve these with easier methods, but right now they want us to solve by graphing. It says you bought a total of 6 pens and pencils for $4. So we know that we have 6 pens and pencils. So I'm going to do big P for pens and PN for pencils. If each pen costs $1, so that's 1P, plus each pencil costs 50 cents, that's 0.50. And we know the total we spent was $4. How many pens and pencils did you buy? So since they didn't say which one is X and which one is Y, it doesn't matter. So I'm going to get them both in slope-intercept form. But I'm going to let this be X and this be Y. And then over here, I'm going to change this to 1/2. And that way I can multiply everything by 2 to get rid of the half. And now I'm going to graph these two equations. And I know they're going to intersect somewhere because the equations are totally different. And my graph is not going to fit, so I'm going to have to make it a little bigger. Okay, so start at 8. And we go down 2 over 1, down 2 over 1. And it makes it so hard if you don't use graph paper. So this is the bottom equation. And then the top one, I start at 6. And I go down 1, over 1, down 1, over 1. And if you notice, it intersects at 2, 4. Remember, my X was pen, so that means I had 2 pens and 4. Okay, so when I got my 2 equations by themselves, and I changed, remember I changed the 50 cents to a half, so I can multiply everything by 2, make it easier to graph. I had to change my graph because it wasn't large enough. So the first one was at 8, and the black, that's this one. and I went down 2 over 1, and I kept going. You just do enough so you figure out where it's going to intersect. And in the first equation, I used pink. And I started at 6, and my slope was down 1 over 1. And I kept going till they intersected at 2, 4. Remember, my X was pens, and my Y was pencils. So that means I had 2 pens, 4 pencils, for a total of 6. And it should equal up to $4 because $2 because each pen was $1, so that's $2. Each pencil was 50 cents, so that would make $2. And 2 plus 2 is $4. And there you have it.